Welcome to IIT Delhi. This is an initiative, the STS event, Sci-Tech Spin event is an initiative by the outreach committee, outreach members of IIT Delhi. And the idea is that, we want to bridge the gap between what we are doing here in academia with the society, and we really want young minds like you, and particularly girls, to get encouraged to pursue higher studies in STEM subjects. So, without further ado, I'll quickly introduce our speaker for today. So it's my great pleasure to invite Professor Neeraj Joshi. Professor Neeraj is an assistant professor of statistics in the Department of Mathematics here at IIT Delhi. He also was a recipient of Young Faculty Incentive Fellowship when he joined. Before that, he was at IIM Kashipur as an assistant professor of decision sciences. Before that, he was also a postdoctoral fellow in the Department of Management Studies at IIT Kanpur. Professor Neeraj obtained his PhD in statistics from University of Delhi in February 2022, and his doctoral research was fully supported by the prestigious Inspire Fellowship. Some of you might even know about Inspire Fellowship. Now he was the top rank holder in MSc Statistics in 2016 at the Kumaon University in Nainital, and therefore he was awarded the Vice Chancellor Gold Medal. Professor Neeraj works in the domain of statistics and data science with specific research interests in areas like sequential analysis, statistical inference, statistical reliability, and statistical quality control. So he has been given several Best Paper Awards, and also and recently he was also given a Teaching Excellence Award at IIT Delhi. So one of the best teachers at IIT Delhi. So we are really looking forward to what he's going to talk about today at the event. So yeah, Professor Neeraj, stage is yours. Thank you.
Yeah, very good morning to all of you. Good to see so many enthusiastic and smiling faces. So as ma'am said, I teach statistics here basically. By training, I am a statistician. And so while looking for searching for some material for this talk, I was also browsing some of the school textbooks. And I was a little bit confused what to talk, what not to talk. And then I came to the conclusion that I should talk something basic, something fundamental, at the same time, which is equally important, equally applicable in practice in real life, so that you can connect the dots or you can bridge the gaps. So, as you know, this program is for to motivate you or to pursue your higher studies, or to motivate you for science and technology driven subjects. And in this particular talk, I will be focusing on statistics, which is the backbone of all the sciences when it comes to data, right? So we all are so we have a lot of data around us in our real life, in our day-to-day life. So, and also I will be focusing on how to look at this data or statistics or descriptive statistics from a different perspective, rather than just being formula or some numbers oriented. So statistics is something beyond that also. So as my title suggests, statistics learning from data. So I will try to connect what type of data we usually gather, what type of data we usually see in practice, and what are the different measurements of scales we have through which we look at the data. So not all methods are applicable for all kind of data, right? So we should think about differentiating these. So, and then I will talk about how this descriptive statistics, I'm sure some of you must have been gone through some of the things called mean or median or mode or some classical probability, conditional probability, binomial distribution, right? So I will try to think how these things, especially this descriptive statistics, comes into picture, which nowadays we also refer to as descriptive analytics in the language of data science, right? So yeah. So if I say what is data? Is data is something only some numbers, some numerical digits, or something like that, some other things also. So data is something like some raw facts or some observations or some measurements or similar things which we collect for some kind of analysis, right? So as I said, data is not only numbers or not only some numerical digits. So it comes in many forms. It depends on the context, which context we are collecting the data or we are dealing with the data. So it depends on the structure, it depends on the time, it depends on the some of the measurement scales also, right? And why we need to understand it, what insights we get from data, that is important. So once we analyze it, once we get to know what is going through, what are the hidden patterns, then only we can think of developing some statistical tools and techniques to deal with this particular kind of data, right? Yeah. I think some of the students are still coming. Okay. So generally, this is a very broad classification of data, right? So generally, we talk about data and we have two kinds of data, like something which is well structured, well organized, or something which is unstructured or unorganized. But that doesn't mean that unstructured data or unorganized data is not important. It is also equally important. We will go through it. How? So generally we have two broader classifications. Yeah. So you see some of the data like your marks in different subjects or your health reports or any kind of data which is like available in some nice tabular form with some names, some columns, some rows, right? Well-defined entries. So this kind of data is referred to as structured data or well-organized data. But we don't have this kind of data always. Sometimes data is available without any predefined format, as you can see here. So this type of data fall into the category of unstructured or unorganized data, right? So how to deal with them? That is the question. As I said, data is not only numbers. You use WhatsApp, you use Instagram, you use Facebook, you go for some medical checkup, some health reports, all this is data. Your voice notes, some videos, you post something on social media, you express your sentiments through social media, this is also data. And this is also very important data. So one cannot ignore this type of data. So you see some of the examples like audios, videos, and emails, or some clickable links available online, or this machine generated data. This all comes into the category of unstructured data. And structured data you all know. As I said, some of your records which is available in spreadsheets or with some nice labels, rows, columns, entries, etc. Right? Or patients' records in hospitals or some bank transactions, or this kind of data comes into the category of structured or organized data. So now the question is, and I'm saying both these data are equally important. You cannot neglect the unstructured or unorganized data. So this is the key question. What type of insight you may get from the unstructured data, which is not available in any set tabular form? So if you look at this second point here, when you buy something from some e-commerce platform, or you browse something, so you want to give your sentiment, your opinion about that product. For example, you buy some clothes, some shoes, some say mobile phone or something like that. So you see reviews are there available on e-commerce platforms or social media tools. You express your sentiments. If I talk about mobile phone, you will express your opinions like based on budget, based on camera quality, based on battery performance, like that. So you express your opinions, and this opinion matters. So a company would definitely like to analyze the sentiments expressed by you, consumers, through the social media posts. So why it matters? It helps them to improve their brand, to improve their product. But at the same time, since it is unstructured, so you have to deal with it very carefully, right? Or similarly, you have this internet browsing pattern. You browse something on internet or even social media posts. After some time, you see there are some advertisements appearing which match your interests, right? So these kind of internet browsing pattern which talks about your preferences, your liking or your disliking. So it helps companies to come up with some suitable advertisements or some promotions for you, for that customer. So this thing is, as you see, it is very important, right? So this unstructured form of data, the question is, can we convert this into a well-organized structural form so that we can perform some good analysis and get some insights from it? That is the key question for the unstructured data, right? So conversion of unstructured data to structured data is very important to understand, to get some insights, what has happened to this data, what type of insights we are getting, what type of patterns we are seeing, right? So to convert it into the structured data, you look at some of the labels, you want to extract some important or relevant information, not all the information. Suppose you see this kind of textual data, which is basically a customer review about a mobile phone. Look at this sentence. The phone is excellent, battery lasts 12 hours, but price is high. This is a sentiment expressed by some consumer, some customer on the e-commerce platform or through some social media posts. So what type of insight you can get from this sentence? So there is some relevant information which talks about a particular thing. It might be a battery, it might be a price, it might be a category, other category. So you categorize them, and then you see whether the customer is saying the product is excellent on some behalf, it is excellent or poor or average or very good, something like that. So you give some numerical digits to them. If, say, for example, if it is very poor, then you can give it 0. If it is like good, you can give it 1. If it is, say, very excellent, you can give it 5, something like that. And you can, after extracting this information, you can make this data in nice tabular form so that it is available at one click, and you get some insight from it. So it definitely helps companies to improve their brand or improve their performance, to give satisfactory results to the customers. So this is the picture. You have some unstructured or unorganized data, which is basically some text, some images, some videos, or some audios. So you want to clean the data first, and then you are interested in extracting some of the relevant information or some of the features of that data. So you note down your keywords, your counts, your objects, and then you define different variables and give some entries to them, give some names or give some numerical digits to them. So in this way, you convert this unstructured or unorganized data into a well-structured form, right? And this you all know, as I said, a very good, well-defined structural tabular data form, where we have some student IDs or roll numbers, student names, their age, in which course they got highest marks. Say, for example, student A got 78 marks in English, which is the highest in any subject for that student. So this kind of data comes into this domain of structured or organized data, right? So this is a very broad classification of data. Now, in practice, sometimes we observe or we get through the data with respect to time, with respect to space, or other things. So we have a few more classifications, which is known as cross-sectional data or time series data, and then we have other kind of data called as longitudinal or panel data. So ultimately, statistics is about dealing with data only. But how to deal with data? First, you have to understand what kind of data you are actually observing in practice. Not all statistical tools. Mean is not always useful for all kind of data. Median is not useful for all kind of data. So first of all, you have to differentiate. You should know what kind of data you are dealing with. So it is beyond the numbers or formulas. So what is this cross-sectional data? You can sense from this figure, this plot also, it means a data which is collected on many variables of interest at the same time duration. For example, for some patients, you are recording the blood pressure, his age or his weight, or some cholesterol levels or some other health records in a particular time period. So this type of data comes into the category of a cross-sectional data, right? Or in some household surveys, one might be interested in monthly income or family size or type of house he or she is living in, electricity consumption. So all this comes into the category of cross-sectional data. You are recording this at some particular time frame. If you look at this time series data, so you are collecting something on some single variable over time. So this kind of data is referred to as time series data. A good example is rainfall data. One might be interested in the average rainfall of different months from, say, past 5 years in Delhi, or average temperature of a day in the last 1 year, right? So this kind of data is referred to as time series data, right? Temperature or rainfall or monthly electricity consumption, etc. Then we have this longitudinal data, where you are interested in collecting information on many variables over different time periods. Say, for example, this annual income or savings or expenditure recorded for several households for several years. So you are, at the same time, you are interested in multiple variables, right? So this kind of data is in the language of statistics, or in the language of data science, this kind of data is referred to as longitudinal data. When you have the information about the category of data, then obviously you would like to know on which scale you can measure this data. Are all scales applicable to all kind of data? No. So broadly, we have 4 scales of measurements in statistics or data science to measure the data. As you see, the data can be some numbers or some quality characteristic also, some names or some labels, right? So we cannot measure these labels in quantitative form. So we have these 4 scales of the measurements of data, which is a nominal or qualitative scale, or ordinal scale, an interval scale, and the ratio scale. Let us look at them, and then we will look at how descriptive statistics is coming into picture, what you are actually studying through your textbooks. Right? You want to say something? No? Okay, fine. So this nominal scale basically refer to, as I said, another name or alternative name for this is qualitative data. That means you are interested in some labels or some names, a very like a minimal kind of data to categorize different categories. So for example, someone might have a blood a group A or B or AB, or someone may have this marital status, either single or married, or a type of vehicle he or she owns. It may be a 4-wheeler or a 2-wheeler. So you see here we are just interested in some labels or some names or some categories, right? So this kind of data, this kind of scale is called as a nominal scale of data. Obviously, you can assign some numerical codes. For example, if someone has a 4-wheeler, I can assign a code 1. If someone has a 2-wheeler, I can assign a code 2 or 0. These kind of numerical codes we can definitely assign. But think about, can we perform any kind of arithmetic operation here? Like addition or subtraction or multiplication or division. Is there any meaning of car minus bike? No. So no such operations are possible here, right? So this is the category of a nominal scale. These operations don't have any importance or any meaning in this context of the nominal scale. Then we have a little bit a broader scale called as ordering data. Again, we are representing some categories, some names or some labels, but with some meaningful order. For example, your feedback about some product, it may be good, it may be poor, so you can rate it on a 5-point scale from 1 to 5, right? So a certain kind of ordering is visible here. You can say that 5 is better than 4, definitely. So although this kind of ordering is permissible or available, you can see, you can sense it, but still the mathematical operations, these kind of mathematical operations are not possible in this ordinal scale also. So only ordering is important here. But hierarchy wise, it is more informative scale than the nominal scale of data. Then this interval scale comes into picture, where you are measuring data on some meaningful order on some intervals, but there is no fixed reference point. If I calculate, I record the IQ levels of 2 students. Say one student has IQ 100 and other student has IQ 200. Although it looks like double, but it doesn't mean anything. A student having IQ score of 200 doesn't mean that he is exactly twice intelligent as someone having IQ score 100. Or similarly, if you look at temperature, here I am saying the 0 doesn't mean absence. If you look at the temperature, 0 degree centigrade doesn't mean that there is no temperature. It doesn't reflect the absence of temperature. Temperature is still there. So this kind of data where there is no fixed reference point is referred to as the interval data, right? But yeah, obviously you can perform these kind of operations, like you can subtract 60 from 120, or 30 degree centigrade, you can add 30 degree plus 40 degree. That kind of operation is possible here. So any data which measures variables such as where ratios become meaningful, this kind of data you record or you go through in your day-to-day life quite frequently, like height or weight or income or some distance. You can perform every kind of mathematical, these arithmetic operations. So this comes into the category of ratio scale of measurement. So information wise, if you look at the information hierarchy, this ratio scale is the biggest one. So hierarchy follows like this, from nominal to ordinal to interval to ratio, increasing information wise. Now when you know what kind of data you are dealing with and what type of scale you can referring to, what kind of measurement scale you are referring to, then this descriptive statistics comes into picture. I am sure you all, at least some of you have gone through these concepts of mean or median or mode, like, okay. Why we need these measures? Are these only formulas, or they give something else? So when I have data, so again, data is different from information. If I just throw some numbers, say for example 1,000 numbers in front of you and ask you to tell me something about this data, you cannot say anything just after looking at the numbers. So what you want, basically you want to extract some relevant information from this data so that you can perform some analysis, or you can predict something. Right? So you want to convert this raw data into meaningful information. And this is where these descriptive statistical measures comes into picture. They help you to analyze your past data. That means what has occurred in the past. Right? And why we need to understand this? So that we can have access to, or we know some of the hidden patterns what the data is showing through some of the numerical measures, or through some of the plots or graphs or diagrams, so that we can sense what has happened, and based on that, what can we predict for the future. So this is where this descriptive statistics comes into picture. You want to convert data into information. So some of these measures, I'm sure you already have gone through. You know the formulas, I know. So for example, the central tendencies like mean or median or mode, they tell about the center of the distribution, you can say data distribution. Or positional, some kind of positional averages like percentiles or quartiles, or what kind of variability you are observing through your data. So we have different measures like variance or standard deviation or some quartile range or something like that. And then you want to look at the shape or distribution of the data also. Then these concepts like skewness or kurtosis comes into picture. So let us go through some of these things first. And then you have visualization tools. So when you look at something, any kind of visualization, it gives you a clear picture of something. If a histogram have the highest bar, you can sense something from it. You can look at what has happened mostly or something like that. So these plots are not just a simple plots, they reflect the patterns of the data. I will not go through this formula. This one can easily like calculate from the given data. But look at this. Suppose I have marks of your marks say for example, class 12th having say 100 students, and say one or two students got say 99 marks out of 100, and the remaining most of the students got marks around say 60 or 70 or something like that. Or to make it more simple, suppose one student scored 100 and others scored 50. So in this case, does this mean or average represent everyone? If you look at this plot, it doesn't reflect everyone in the class. Based on this number, you cannot say anything about the performance of the class. So it might be misleading in this kind of data set. So this 100 is an extreme observation, or in the language of statistics we call it outlier, an outlying observation. So mean is not a very suitable average here to give the true picture of this data. So what are the important observations? It may get affected from the extreme observations or outliers, as you can sense from that plot. So one can safely say it is not a very good or suitable measure for skewed data. Skewed data means where many values are clustered around the tail, or you can say around some point, and then you have some kind of skewness towards right side or towards left side. And also, I have now already explained this qualitative data, where only we are referring data by only names or some labels, and you can see arithmetic operations are not possible there. So obviously mean is also not possible. So this measure is not a very good measure, even not applicable to deal with the qualitative data. You need something else. And also, two groups may have same means, but still they might have a different variability. So mean alone cannot be understood as a very good measure of reflecting everyone from that group. You have to look at some other things also, variability also. Then you have this average called median, where you are interested in the middlemost portion of the data just by ordering in some ascending or descending order of magnitude. Look at this slide. See, if one student tops the class, should that decide how good the class is? So here you see it is representing a typical student from the class, right? After arranging the data in ascending or descending order. So you say that in a very skewed data, or when outliers are there, this is more robust than the mean. And also you can use it to deal with the qualitative data. If you have some rankings, 0, 1, 2, 3, 4, 5, still you can find out the middlemost ranking. So it can be used to deal with that kind of data. So it is not affected by the extreme observations or the outliers, and hence suitable for these skewed observations or skewed data, although it ignores many observations. Then you have a very good measure called mode. You are interested in what value is occurring most of the times in the data. So if I look at this marks, these scores, what score occurs most often in the class? You can just look at this and one can say that 60 is occurring most frequent in the class. So most of the students got 60 marks out of the 100. So it gives you a picture about what is actually most popular or most normal in your daily day-to-day life decisions. You are influenced by these kind of things, what is happening most in the society, what is happening most around you. So mode is a true average in that kind of sense. Then we have some positional measures. You must have heard that some student got 99 percentile in this exam. So you need to understand what does it mean. What is the meaning of a student getting 99 or 98 percentile in some exam? So this is where these positional measures help you to get insights from the data. So you have different type of positional averages like quartiles. As the name suggests, you want to understand data in the 4 halves, where the first quartile represents that 25% of the observations are below it, or 75% observations are above it, or maybe the second quartile represents the 50% observations are below it and 50% observations are above it, right? So this is called as quartiles. So this helps you in data visualization or measuring this variability or identifying some potential outliers or extreme observations in the data. As I said, this percentile means you are interested in the 100 equal parts of the data. So look at this figure. If you are in the 90th percentile in some exam, what does it actually mean? If you look at this plot, so that means in that exam you scored better than 90% students. If you have 99% percentile, you scored better than 99% of the students in that competitive exam. So it is reflecting your position in the data, right? And this position is also very important to understand. So this is where these positional averages or positional descriptive measures helps you to analyze the data, right? As I said, 2 groups or more than 2 groups, even more than 2 groups, they may have the same average. For example, 2 sections of class 12 may have the same average marks in some subject, but still there is something hidden. Maybe that average is coming from a very dense marks, or maybe that average is coming from the scattered data, where the observations are scattered. So you need to know what kind of variability this, or what kind of deviation, or what kind of dispersion this data is actually reflecting. So this is where these measures of variability or measures of dispersion comes into picture. So how data is spread around the center of the data, center of the distribution. So these are some of the common measures of dispersion which we deal with in statistics. Obviously, there are other measures also. So one such measure is which is a very crude measure, I will say, where you are just focusing on the maximum value and minimum value in the data. So this reflects the dispersion in the data, but the disadvantage is that here you are using only the extreme observations. For example, if I want to answer this question, is class performance uniform or very different? So you may look at the ranges of different groups that can give you the idea of this kind of variability. Then you have this interquartile, as I have already explained the quartiles. So if you look at the middle portion of the data, middle 50% of the data, it will give you some kind of information about the outliers towards upper side or towards lower side. So you can sense something beyond that range. So this is equally important for analyzing variability in the data. So you can easily detect extreme observations, and these extreme observations sometimes appear randomly, sometimes due to some mistakes. So you can, in any case, you need to identify them, and then you can develop some statistical tool to handle these outliers. I'm sure you must have gone through the formula of this sigma square or variance, what we call as variance. But what it is actually reflecting, that is very important. So since you see that we are squaring these differences, so we want to understand the variability about the average, and we are squaring the observations. So we are giving more weights to the larger observations. But this squaring is sometimes, it might be sometimes misleading, especially when you have to deal with some units where square of the unit is doesn't make any sense. So we have a very a good measure which is related to that, which is basically nothing but the square root of the variance, where this unit thing is now not coming into picture. That squaring units is not coming into picture. But the question is, again I am repeating, two classes have the same average marks. Are they equally good? So you can answer it after looking at the variability only, or after looking at the standard deviation only. If you look at this blue or red curve, you can sense that one is reflecting a very low spread of the data around mean, and one is reflecting the very high spread around the mean. So this small spread is representing the consistency, you can say that, and this large spread is explaining some kind of unpredictability in the data. So while using average, you should use variability also alongside, so that you can say something about the variability of the data as well. Then we have one more measure, which is basically here the standard deviation and variance both are coming into picture. Basically you want to give some relative dispersion of, or relative variability in the two groups. So after going through this, all these data types you are dealing with, or all kind of scales of measurements, or all of these the descriptive measures, you want to get some more insights which may be related to what type of shape it is producing, or what type of, whether it is symmetric or it is asymmetric, or it has a longer tail towards positive side or longer tail towards negative side. So all these things helps you to get more insights from the data. So we have some measures here, like skewness, which measures the degree of use. You have seen that in that marks example, if say more students have marks around say 80 to 90, then it will look like a left skewed curve. So more observations will be clustered around 80, 85 or 90, and less observations will be towards the lower side. In other way, sometimes more observations are like clustered towards the lower side, or then it is scattered towards the upper side. So this reflects some kind of skewness. You call it positive skewness or negative skewness of the data. This figure, this plot reflects it. So I want to answer, do most students score high and few score low, or it is opposite? You can sense it from after looking at this plot. Most of the students are clustered around that highest marks range, So you can sense it is producing a left skewed or negatively skewed plot. So these kind of visuals you get for positive and negative skewness. If there is no skewness, we call this data as a symmetric or a symmetric distribution. So this kind of relationship holds for between these three very important measures called mean, median, and mode when the skewness comes into picture. And along with the skewness, you also want to know what kind of tail thickness or what kind of peakedness is there. So that is nothing but a measure which is called as kurtosis. So basically you focus on the extreme values or tails of the data like this. So our data can be like more flattered or more spread, you can sense from it. So these are these three things are reflecting three different kind of kurtoses. Okay. So now you have the idea of what kind of data you are dealing with, or what kind of user measures you want to deal with a particular kind of data. You have some descriptive measures. So it is reflecting basically what has happened to the data. To get more insights, to get to know some patterns or some hidden patterns, you want to rely on some plots also. You want to rely on some visualizations also. So these visualizations are equally important along with these numerical characteristics. So I am sure you must have idea of this histogram or bar diagram or pie chart. So these charts or these plots are basically giving us some visualization, and all charts are not useful for all kind of data also. So basically in the terminology of data science nowadays we call it exploratory data analysis. So these are parts of the exploratory data analysis, hence crucial for decision making in any particular situation. For example, the question is, how are students' marks spread across score intervals? So you see the key observations here, whether these bars touch each other and the marks are grouped into interval. So you have very small intervals or maybe moderate intervals, and you want to check the marks is obtained by students in that interval. So this curve is showing you this distribution of the continuous data, right? The touching bars means these are continuous intervals basically. So it is not only about marks. For any kind of data, if you look at this plot called histogram, you can sense the spread across intervals. If I am interested in knowing which score group has the most students just by looking at the plot, so you can see that here each bar is representing some separate category. For example, 40 to 5 or 50 to 60 or 60 to 70, something like that. So so this bar chart is basically comparing different score groups inside the marks data. So a difference is that this histogram is very useful for continuous kind of data, whereas this bar chart is more useful or more utilized or more suitable for categorical data. Sometimes you see these kind of pie charts in while watching cricket matches, or these charts appear to reflect the different kind of data, or in newspapers to know some characteristic. So what is the key idea here? So these all slices as a whole, they reflect the 100% of the data. They represent the whole class. The key question is, how is the entire class divided based on the marks. So you can say that 23% and 33% or 44% or 50%. You can create different categories inside that pie chart. Obviously, if there are, if you divide it into more proportions, sometimes it may not look very good. So you have to deal with it with a very optimal number of proportions. You cannot say, for example, if there are 100 proportions or 90 proportions, so it will look very weird. So optimal number of categories should be there to use this pie chart. Suppose I want to know, is there a relationship between study time and marks? For example, if you are studying for 8 hours or you are studying for 5 hours or 10 hours, is there any relation with the marks obtained by you? So you can sense it using this scatter plot, where x-axis representing the study hours per day and y-axis representing the corresponding marks. So you can see a plot which is going towards increasing direction. So rising pattern you can identify from this plot, which reflects a positive relationship. So it is not giving exact prediction, just showing a relationship, a positive relationship. Yes. So what next? Is the statistics is only about this descriptive measures or plots, or we have anything else to do? So I wanted to focus on this descriptive part only in more detail because you are more familiar with these kind of measures. But remember, these things are not only formula oriented, or you just deal with some numbers, some formulas, get some answers. There is something more hidden in all these things. So what beyond? What is beyond it? What is beyond descriptive statistical measures? So, as I said, a lot of uncertainties are around us, lot of randomness is around us. So you want to make some prediction using statistics. After analyzing the data, after looking at the data, after looking at the hidden patterns, after going through some of the descriptive statistical measures, you want to predict something based on that. And the decisions, especially in this data-driven world where data is everywhere, a very complex data we are getting in all domains. So your decisions should be data-driven, not just random. So this is where this description to prediction comes into picture. Descriptive statistics or descriptive analytics to predictive analytics or prediction. You want to predict something also. The questions like what is the average, what is the most common value, this is all fine. But at the same time, the key question is what will happen in the future. This is called statistical forecast or statistical prediction. You want to know, will it rain tomorrow based on the data, based on the past data? Or will a student pass the exam? Will a machine fail soon? So these kind of predictions you should do using this after analyzing this data through descriptive statistical measures. So you want to develop some statistical tools that help you to predict these things. And why I am saying about there is a lot of uncertainty around us. You see that these weather forecasts are sometimes not 100% true. Yes.
Sorry to interrupt in this interesting talk, but there's a lot of murmur going on at the back. So, there are students still interested in between, and this is sort of also distracting for Professor Neeraj to present. So can we please keep quiet? If you don't understand, there'll be plenty of opportunity to ask questions after the talk is finished. So please keep quiet and listen to Professor Neeraj. Thank you.
Yeah, thank you. So why this uncertainty and how this uncertainty is coming into picture? you see that these weather forecasts are not 100% true, or you sense that in real life, or these medical tests are not, you cannot say these are 100% perfect. Exams always, they don't always reflect the true ability of the student. So the key question is, how uncertain are our answers after looking at the data, after reflecting the data? How much trust we have in the data? These are the key questions. So you cannot, as a statistician or as a data scientist or as a data analyst, you cannot ignore uncertainties. You have to focus on them, and you have to develop tools that can deal with these uncertainties nicely so that you can have better forecasts. So data-driven decisions are always best. You cannot just say anything randomly out of nowhere. Your decisions should be data-oriented in any domain. For example, you see that doctors treat you based on your reports, not randomly, or not just out of nowhere. Similarly, you see that the government plan policies using the census data. The census is conducted every 10 years, then they have a lot of data, and based on that policies are planned. Or the companies improve their products, as I explained in the initial slides, using your feedback. So a good data, when you have extracted information from the data and you have done some good analysis, so as a whole, this good data and good analysis gives you better forecasts or better predictions or better decisions. And statistics is everywhere, in biology also, in other sciences also, in engineering also, in all the domains, even in social sciences. So since data is everywhere, so statistics is everywhere. And nowadays you often talk about these things, whether artificial intelligence or machine learning, economics or medical research or some other kind of research, data is everywhere. So statistics is like a backbone when it comes to data in all these domains. Every field that uses data, you have to rely on, you have to use the statistics. And nowadays, with a very good scientific tools we have, you don't worry about computation. You can do a very complex calculation, you can analyze a very complex structure using different programming tools or other tools. So these are some of the tools which helps you in analyzing data or making some forecasts, like this R software or R Studio, Python programming, other type of packages or tools. So all these help you, don't have to worry about too much computation. So this is what I wanted to talk about. Whatever you are observing through your textbooks, whatever knowledge you are getting, just don't focus on only on formulas and these numerical digits, and so statistics is beyond that also. So look at it from a different perspective, because nowadays in any field you have to rely on data driven decisions also. So if you don't understand them correctly, it is more likely that you will produce incorrect forecasts, which is not a very good thing. So you ask the right questions, you think logically, you learn from data. So it's not about numbers only. You want to understand the uncertainties around us, you want to make good forecasts, so that as a whole this data science or statistics can serve you, can serve the society well. The purpose should be served. So this is what I wanted to talk about, and I'm sure some of you must have got you find it maybe motivating. So you can ask questions if you have any questions, any doubts, any queries even. Please ask. Some of you may have some queries.
Sir, I did not understand how we can calculate variance. Would you please let me know
How you can calculate variance?
Yes, sir.
Oh, okay. So variance is, first you understand what is variance, why we are calculating variance. Yes. So you want to know the variability, the spread around the mean, right? So you are interested in something. If your data is represented by say X and the true average is say mu, so you are interested in that spread or that variability. Why we are taking square of that distance? Some values may be positive in the data, some values may be negative in the data. So sometimes that may produce some kind of incorrect if the observations are like cancelled out. So that's why we are taking the square distance instead of the actual distance. So it is just the spread of data around the mean. That formula basically is reflecting this thing.
So
Yes, any other question or any other query?
So my question is that we know that adding more data,
Yes, please.
so we know that adding more data, it makes our data, the mean and mode and median, it makes it more accurate. But at what point do we determine that adding more data or increasing the sample size further is not benefiting the statistical model? Like we cannot simply keep on adding more data and expect it to become more accurate. So what is the limit?
We are not keep on actually in fact I have not covered this sample survey part, but a very nice observation and very nice question. We are not keep adding data. Data is coming to us. You cannot stop like the data coming to you. Data is coming. Data will come. Very complex data sets will come. The question is, you have to design, you have to develop the statistical tools. Since you are talking about samples, obviously we have very large populations and numerical characteristics representing those populations are unknown in practice. So you want to estimate them, you want to make some inference about them using the sample data, right? So this is not like we are continuously increasing the sample data. No, it is not like that. We have some statistical tools, we have some restrictions, we have different estimators, we have different conditions on them. Based on them, we design our samples. You look at this election forecasts, where some exit polls or opinion polls are there. So if they are conducted like scientifically using some very good probability tools, very good statistics tools, you see that most of the times or even 50% of the times they give the actual results, but they are based on a very small data set. If the total size of the voters is say 20 crore or 50 CR, but you see that the sample size is very small. So we can, in statistics, using statistics, we can do very good forecasts using very small sample data also. So it is not just like that we are adding numbers. That's not like that.
Sir,
Yes.
I am Yash Sisania. So my question is, suppose we have two data sets,
Yes.
A and B. Data set A is feeded and
Data
into
set
an
A
AI.
is what? I didn't listen carefully.
Data set A and B both are fed into an AI through machine learning.
Okay.
And data set A is giving more accurate answers while data set B is not giving too much accurate answer.
Okay.
So what could be the possible reasons behind it and how AI can contribute in it?
Yes. So that means if it is not giving an answer which you wanted it to give you,
Yes, sir.
that means there might be some mistakes in your model. That means you have not chosen your model like more appropriately. So as I said, not all models, not all statistical models, or not all data driven models are useful or suitable to deal with all kind of situations, right?
Yes,
So
sir.
in the backbone of this machine learning, statistics is working. So that means there is some mistake while choosing the appropriate model for the data. That is one of the biggest reason that you have not chosen your models, or you have not included all the parameters. You have excluded some parameters, some relevant information. So because of all these things, that kind of error may occur in practice.
Sir, and how AI can help in it?
How AI can help you?
Yes, sir. Sir, like for example, data scientists feed some data into an AI and the answers are generated. So, will
Your
it not-
voice is not very clear actually. Please ask loudly.
Sir, like a data scientist feed
Yes.
a data into an artificial intelligence.
Yes?
So, will it not replace the data scientist itself?
You are not what?
Sir, will it not replace the data scientist itself?
Yeah. Yeah. It is AI will replace data scientists or not?
Okay. Oh, no need of humans.
Yes, sir.
Oh, okay. A very courageous question actually, I would say. So if you look at this chat, you use ChatGPT?
Yes.
Of course.
Yes or no?
Yes, sir.
So if you look at the answers of the ChatGPT, so there is some library, and
Yes,
that
sir.
information is coming from that library. So it has limitations. AI has limitations. So it will give you only that information which is available in that memory or that library. That's why you see that many times the answers of ChatGPT or AI are not accurate. So it's not like that why humans are needed or why data scientists are needed. Actually, data scientists deal with that to improve these AI tools. So it's other way around actually.
Thank you. Thank you.
So when you ask question, please tell me your name also and from which school you are.
Very good morning, sir. This is Dakshi Bhatia from Surajmal Vihar SOSC. So, sir, my question is when we have a data and then we have a probability regarding it, that what is the chances of this or what are the chances of this result? We have the prior information that it is like, for example, 50% chances that it will rain today. But now we have a new evidence or a new probability that is affecting the older probability. Let's say if it's thundering today and we have this probability that if it thunders, 90% chances are there that it will rain. But now my question is, in machine sciences or in AI, one thing like millions of things are affecting a single probability. There are so many things that affect a single probability. So how can we even calculate the prior probability and how it will affect it?
So basically you are talking about base probability,
Yes, sir.
right?
Yes, sir.
Where priors play a very important role in deciding the posterior distribution or posterior probability, right?
Yes, sir.
So in statistics we have a separate branch called Bayesian statistics, which over the years which has evolved a lot, right? In fact, we make our predictions, we make our decisions based on the prior data much more in comparison to the frequent test approach. So it is based on the quality of priors you are using actually. We have different type of different categories of priors in statistics. We don't always rely on a particular kind of prior to deal with all situations, right? So these priors are along with the corresponding probability distributions need to be understood, right? So probability distribution plays a very important role there. So you don't need to worry about that. We have different priors to deal with different situations.
Sir, but in a case, if there are millions of things affecting a single probability, then how can we
Millions of what?
understand?
Millions of?
Sir, if there are millions of things that are affecting a single probability, millions of cases affecting a single probability, then how will we know how will we know how much accurate is a probability we are getting in the end, and what are the parameters on which we decide which probability we have to take in consideration?
It's not about single probability. It's not about single probability. You are not just focusing on a single value. You are actually using that probability along with other things also. So as I repeatedly said in my talk also, you are just not relying on one thing, one probability, right? You have other things also, whether they support your claim or not. So all things together as a whole, you will make some forecasts or some decision. It is not like that you are just calculating some single probability or giving your result. It is not like that actually in practice.
Okay, sir. Thank you so much.
Hi, sir.
Yeah, what is your name and from which school?
Very good morning, sir. My name is Shubh Gupta. I am from SOSC SMV.
Yeah.
Sir, my question is that is it
Other
necessary?
students, please keep quiet so that
Is it
you
necessary
also
that-
can listen his question actually. Please keep quiet.
Is it necessary that if we have more data, it always give us better analysis than less data?
No. That is the first student who asked question about sample data.
Yes, sir.
My answer would be again the same. You cannot stop data. Data is coming. Okay, fine. You have a very
Sir,
large.
but if we have less data, then it is better than more data.
No. It is not like just you are adding up on collecting the sample data. You have other things also. In fact, you have, while collecting data, you have this budget or time constants also. You cannot indefinitely keep on collecting the data. So we have such sampling tools, such optimal sampling plans. Utilizing these plans, utilizing the techniques, we can balance out the data collection and at the same time considering the cost or time constants. It is not like we keep on collecting data. No.
Thank you, sir.
Hi, sir. I am Akash Kumar.
Yes.
I am assistant commandant in BSF, and here,
Okay.
and I have with me my students from Kashmir.
Yeah,
they are
nice,
on Bharat Darshan tour.
Yeah.
And one of my students in Kashmiri, he asked me, he had a question.
Yes, please.
And basically his question was related to elections. During elections, we see many exit polls, opinion polls. So what kind of data we use there? What kind of analytical tools we use there? So in layman terms, they want to know.
Yeah. So in these election forecasts, so first of all, you need some of the information from voters, right? About their preferences, about their choices, what kind of politicians they like, or other things there. So you don't directly ask. So if you go and you directly ask someone to whom will you vote, it is more likely that he or she will not give you the correct answer. So usually people are hesitant to talk about such things, right? So we have different techniques. We frame our questions, our questionnaire such that we don't collect basically direct answers. So we try to collect this information indirectly, using framing some questions like that, so that we don't need to know exactly to whom you are giving your vote. So yeah, we have several randomized techniques, sampling techniques there. So based on them, we frame our questions, and then we, instead of just asking one direct question, we try to ask, say, 10 questions or 20 questions on different aspects. What are their issues? what are their choices, what type of development they want in their area, and etc. etc. So these actually decide their, as a whole, their motive or their opinion about some election. So it is not like that we go and directly ask whom you vote. They will never give you the exact answer, and you don't get anything actually in that scenario. So we have a different. There is something called randomized response technique in statistics, or other techniques also in sample surveys. We utilize them and we get what we wanted to get. Yeah.
Sir,
Yes.
sir, sir,
Yes. Yes. Please.
sir, I am Aditi from Kendriya Vidyalaya JNU, and my question is that I understood from a presentation that numerical to categorical data, it can be converted easily, but can it be done in a reverse way, that categorical to numerical, can it be done that way, and how AI can help in that regard?
So you are saying if you have some categories, here you go. This one. Yeah. So you are saying basically if you have some categories, can you convert it into numerical data?
Yes.
You can assign some numerical codes. Maybe suppose as you consider that feedback example, you are rating something on a 10-point scale.
Yeah.
So instead of giving these, writing these names like poor or good or excellent, obviously you can assign some numerical codes like 0, 1, 2, 3, 4, 5, something like that. But the main thing is the kind of arithmetic operations which you do in quantitative data, obviously it is not possible there.
Yeah.
You cannot add, there is no meaning of adding names or labels or subtracting or division or any kind of, right?
Yes.
So this comes under the domain of this qualitative data, and we have different statistical tools that can help you to analyze it.
Okay.
So there is no need to like that kind of conversion.
Okay, thank you.
So, good morning, sir. I am Aditi from Imperial Heritage School.
Yes.
So, my question is that where the coefficient of variation is used?
It is not clear actually.
My question is that where variation of coefficient is used? My question is that where coefficient of variation is used?
Where coefficient of variation is used.
Yes.
Suppose you want to compare two heterogeneous groups where variability is like different. So, right? So, first of all, you need, so basically you need a relative comparison. You cannot directly compare these two categories. If you want to compare the GDP of two countries, for example, India and some other very low income country, so you cannot directly compare these. You have to compare it using some relative variability. First, you analyze it with respect to their average, and you analyze the other group with respect to their average, and then you compare them. Because of that kind of variability, you cannot compare them directly. Yes, you want to ask any question? Yes.
No, good morning, sir.
Yeah,
my
what is
name
your
Paresh.
name?
My name Paresh Yadav from CM Sri School, Chilla Village.
Yeah.
Sir, my question is that what conceptual mistakes the student makes in statistics to pursuing masters in higher studies?
What mistakes?
Yes, sir. Conceptual mistakes.
Conceptual mistakes.
Yes, sir.
Regarding what? So your question is regarding some.
Sir, my question regarding just as I want to pursue higher studies in statistics.
Okay.
So what conceptual mistake does the student makes? Does the student makes that?
Yeah, I got
prevent
your
them
question.
from
Okay,
studies?
I got your question. So I think in this talk I focused on that also. right? So here you see that, so for example, you are doing some descriptive statistics, right? So I have told you that you should not measure all kind of averages to deal with all kind of data. You have different kind of data, right? Similarly, you cannot calculate conditional probability always. You cannot use Bayes theorem always, right? So you have to look at the context on which you are actually working. If that context is clear, that's why I first focused on data types, not directly came into the statistical measures. So first you understand you have this conceptual clarity of what kind of data you are dealing with, then the things are much easier. Then you know that which tool, because you know that which tool is meant for which kind of data. That makes, and obviously over the time you learn. If you go for higher studies in statistics, so you will learn over the time, you will learn different techniques. So it will definitely help you.
Good morning, sir. I'm Kritika from PM Shri KV number 1 Delhi Cant. I was curious about how can we identify lies which are statistically true?
What? Please repeat again.
How can we identify lies which are statistically true?
Okay, how can you identify lies which are statistically true?
Yes, sir.
So for example, you have some data, maybe some qualitative data, and you are performing some analysis, and say for example you are doing some you are trying to do some quantitative kind of work in qualitative data. So obviously that will not give you anything that is like beneficial. So you can easily identify using different tools. You can statistically reject it or accept something. In statistics there is something called statistical inference, where you want to prove or disprove some hypothesis or some claim about some numerical characteristic, right? So we have different kind of tools. We analyze the errors. We have two kind of errors there, and then we have that testing of hypothesis approach, using which you can easily identify these fallacies around the data. So we have tools. Using these tools, these inferential tools, you can do such kind of thing.
So what about casual data?
Okay, yeah.
So what about casual data where the data is true but the conclusion which comes is wrong?
Then that means there is some mistake in your analysis, some mistake in your part. You couldn't analyze it correctly. You couldn't understand it correctly. So you have to revise your approach, so that you can come up with some more appropriate approach, and that's it.
Okay, sir. Thank you.
So one last question we can take, I think.
Good morning, sir.
Yeah.
Sir, I am Abhibhav from DLF Public School. Sir, over here. I'm Abhibhav from DLF Public School.
Yeah.
So as you mentioned earlier that small data sets can also be used sometimes instead of big data sets. I wanted to ask that sometimes small data sets can be biased, as it may be from the same group set. What are some techniques we can use to make sure that the data isn't biased?
Data set can be biased.
Yes.
Okay. So,
for example, we are from the same school. So if you collect data from our school, it may be biased.
Why it can be biased?
Because a common group is giving the data, providing data.
No. Actually, it is not like that. Data, I cannot say data is biased. You should say like your approach is biased or not. Your approach of collecting data is biased or not, right? So we cannot say that data is biased. Instead of that, we can say our approach can be biased. So yeah, we have to use the most appropriate approach to collect the data, whatever things we have in hand.
But sir, then how can we ensure that the data collected is not biased and collect from various places?
Again, I am saying don't say data collected is biased. Say your approach is right or not. If your approach is not right,
Yeah,
it
I was asking what
in
the
the
right
reflect in
approach
the
is.
analysis. It will reflect in the analysis. So it will not give you anything. It is like a misuse of statistics. It does not give you anything.
Okay, sir.
That's it. Yeah, one last question we can take. Obviously, you can, if you have many questions, other questions.
Good
I have
afternoon,
shown
sir.
my email ID here. You can send it to me, write to me also.
Good afternoon, sir.
Sir, myself Manthak from Mount Karun School. My question was, what actually is quartile deviation and what is the use of deviations?
Yeah. So these deviations are basically useful in identifying the, for example, if you are particularly focusing on quartile deviation. So if you look at that difference of third quartile and first quartile, so it is giving you the picture of middlemost data, middlemost observations, middle 50% of the data, right? So while studying averages, I'm interested in the central tendency or middle part of the data, right? So beyond these, beyond certain limits or beyond these quartiles, you can say that this kind of data is like outlying observations or extreme observations. So then once you now you know that you have outliers or extreme observations which can be present due to some errors or present like they should be there can be outliers by default also. So then you deal with them and you develop some statistical tools that can help you to analyze these outliers. So these deviations helps us in understanding these extreme observations or outlying observations.
All right, thank you. That brings us to the end of this event. Thank you, Professor Neeraj, for this really exciting talk. I'm sure, how many of us are biologists here who like to do biology more than maths? See, there are quite a few. So, when I was young, when I was back in school, I was thinking, I would either become an engineer या फिर bio की तरफ जाना है. Stats से मेरा क्या लेना देना? But, if you look at biologists now, and like Professor Neeraj, how he showed, although I am neither a biologist nor a mathematician now, I do climate sciences, which again applies a lot of mathematics. Like, we use a lot of data to predict कि कैसा climate change होगा, कैसा weather. So, what I'm trying to say, statistics, which I as a student used to think is just mathematics, इससे तो मेरा कोई लेना देना ही नहीं होगा. Biologists use it, people in AI, ML, politician exit polls. There was a question from here. So, it's just used everywhere. And Professor Neeraj is around for a bit while you exit. And there are also refreshments just outside. So when you go out, feel free to talk to Professor Neeraj. And also there is a QR code where you can scan and provide your feedback. This initiative started a few years back where we wanted students from all disciplines to come and see the kind of work we are doing as researchers, as professors, as teachers at IIT Delhi. So, so all those talks that have been given, you've come here in person for this talk, you might not come back again, or you're welcome to. But there are, all these talks are there online on YouTube, so you can go to Sci-Tech Spin IIT Delhi outreach page, and there are all these talks from biology, from climate, from materials, from physics, electrical engineering. So, all the disciplines that are covered here at IIT Delhi. It's a monthly feature where one of us comes and present their research or their area. So, so I thank again Professor Neeraj. We would like to present a small token of appreciation to Professor Neeraj.
So one last thing I want to say, hope to see some of you in future in IIT Delhi. Thank you.